All right, so we're looking at example 7 from our optimization notes. It says, an indoor physical fitness room consists of a rectangular region with a semicircle on each end. The perimeter of the room is to be a 200-meter running track. Find the dimensions of the rectangular region of the track that will maximize the area of the rectangular region. Okay, so we've got a picture here. Let's see. And we've got the rectangle in the middle, and then we've got our two semicircles, on the outside. We know the perimeter of the room is 200. So our perimeter is going to consist of these two semicircles and then these two widths here. So we need to find some way to represent these two widths. So I might go ahead and say each of those are a length of x. And then for the semicircle here, we can, what if we look at just the radius is going to be half of this height of this rectangle here. And so the circumference of a circle is 2 pi r. So the circumference of a semicircle is half of that. Half of 2 is 1. So it's just going to be pi times the radius. And if we just call that r for now, we can say our perimeter is going to be these two x's and 2 of these pi r's. Okay, to find our perimeter. Now, is that what they ask us to maximize? No, that doesn't make sense because we know our perimeter is 200. They ask us to maximize the area, okay, and to find the dimensions. So let's state what our final answer is going to be. Okay, the dimensions of the rectangle should be blank. Do we have units here? We got meters. I'm gonna go ahead and say, because of the way the picture is drawn, wide by blank meters. Tall is not really the right word. What's a good word for that? Yeah, I don't know. Linked. Whatever. We don't have to put a word there. All right. The width just tells us that this is our width here because they should be different. We'll see. All right. So this is going to give us, these dimensions are going to give us our maximum area of the rectangular region. So that means we need our area formula to maximize. That's going to be our optimization formula. The area of a rectangle is just length times width. Let's see. Our width is x. Our length is just 2 of our radii, right? If we were to rotate this around 180 degrees, we get 2 of our length of our radius there. And so now we've got our area, but it's in terms of 2 variables here. So let's look at our constraints for those first before we go any further. All right, so x constraints. If the perimeter is 200, it's got to be less than half of that because the perimeter's got twice that in there. So it's got to be less than 100, and it's got to be more than 0. Okay, non-inclusive. All right, our radius, it's got to be bigger than 0. That's as far as I'm willing to go for right now. Obviously, it can't be 200. It can't be 100. I don't know. We could probably go smaller than that. But we know it's got to be less than 100 because that would make those sides. Actually, we could say 50. Could go as low as 50. maybe even lower once we get a little further, but it's got to be at least less than 50. All right. What next? We need to rewrite our optimization formula in terms of just one variable. Okay, so how can we do that? Well, we've got our perimeter up here. Let's see, I'm going to move my constraints over a little bit so I can work on that perimeter equation. Okay, so we know that our perimeter is 200. We also know that it's equal to 2x plus 2 pi r. So we kind of have a choice as to which one that we solve for. I'm going to solve for x. We subtract 2 pi r from both sides and then divide by 2. 200 minus 2 pi r divided by, divided by 2. We can simplify that. 200 over 2 is 100. And 2 over 2 is 1, so minus pi r. Okay, so now we got our x in terms of r, so now we can plug that into our area formula in place of x. Okay, so now we got our area formula in terms of one variable. Before we go and take the derivative of that, let's rewrite it, simplify it in a more differentiable form. So I'm going to distribute that to r. So that gives me 200r minus 2 pi r squared. Okay, nice. Okay, now I want to find a prime. Find what that is and set it equal to 0 and undefined to find our critical points. All right, so we can take this by hand. 200 minus, and we're taking the derivative with respect to r. So 2 times 2 is 4. Pi is just a constant, so it's part of that coefficient. And then r, why did that change? I don't know. R to the first power. Let's try that again. Okay, boom. There's our a prime. That's linear. Makes sense. It comes from a quadratic in A. We had a negative leading coefficient up here. Are we looking to maximize? We are looking to maximize. Good. All right. So let's find where a prime equals 0 and where a prime is undefined. All right, our a prime is linear, so it's not undefined anywhere for any r values. And if we set this equal to 0, what do we got? Minus 200 divided by negative 4 pi. Negative divided by negative is a positive. 200 divided by 4 is 50. So we've got r equals 50 over pi. Okay, I'm going to leave that in terms of pi. Obviously, we could have put this into our calculator if this is a calculator active problem and gotten a rounded a decimal. I don't mind dealing with pi's. This will give us a more exact answer as well. Okay, and again, this is linear, so if we want to do a little sign chart here, then what does a prime tell us about a? We've got a linear function with a negative slope, so it's looking something like that. So we go from positive to negative, which means our original function changes from increasing to decreasing. So that verifies that we have a max at r equals 50 over pi, since a prime sign change positive to negative. Okay, so verified that our extremal was a maximum. We found our r value that is between these. I don't know what 50 divided by pi is, but it's positive and it's less than 50. So what do they ask us for? Dimensions of our rectangle. Okay, so we need our width, which is exactly x. We don't have x. We have x equals 100 minus pi r. So let's find that. 100 minus pi times the r value we just got was 50 over pi. Ooh, glad we left it in terms of pi, because now we can, and now we got 100 minus 50, which is just 50. All right, so it's going to be 50 meters wide. And so now our height or length, whatever you want to call it, is going to be r. So it's going to be 50 over pi. It's going to be twice that, right? So our length was twice r. So that's 2 times 50 over pi. So we can just leave that as 100 over pi. Again, if you did that A prime solving for equal to 0 in your calculator and you got a decimal there, that's fine. Just make sure you round it to the nearest thousandths and make sure that you put it back in our solution that we boxed up at the beginning.